Hello friends, in this video tutorial I'm going to show you how to use Synopsys Design Vision to synthesize your Verilog codes into the netlist. So basically you will be having your Verilog code with you and you will be using standard cells from OSU TSMC 180 nanometer, and you will be finally eventually translating your behavioral code in Verilog to a netlist. So to start with, I've kept all my Verilog code into a folder named source. If you want to look into it, these are all the Verilog files. I'll be trying to synthesize one simple mux. So let me show to you my Verilog file. So you can see that I have defined a mux in a behavioral fashion using a case statement. I put in a case statement on my select line, and depending upon its level, either my input 1 or input 2 will be routed to the output. So to synthesize this, I'll be making use of a script. We can also do this with the help of a GUI support, but there are many parameters to be updated for a GUI. Scripting is a very easier way. It will automatically, you just quote all the environmental variable at once and it will be automatically taken care by the script. You just need to issue the script and it will automatically be synthesized or compiled. So I'll make you have a look at my script as well. My script is synthesize.tcl. It's available in the main folder. Let me change the directory. pi synthesize.tcl. This is my script which I need to run. There are certain fields into this script where you need to update accordingly. The first one is the location of your Verilog file. Since I am having my all Verilog codes in a folder named source, and the Verilog file I am compiling is mux2_1, hence I have updated it accordingly. With the top level module, maybe your Verilog file consists of very small instantiation of other modules as well. So this is a top module. For example, if I want to design a ALU having a function of multiplication, division, addition, subtraction, maybe I am having all these modules separately and I'll be calling them all together in my one big module or top module ALU. So here is that name of that top module. Because my multiplexer is just a single file, so both are the same. My top level is also 2_1. Then your clock pin. If your design include any clock term input into it, so you may quote your clock port name. Otherwise, you can select any of the input pins if you have if your design isn't having any clock. This is a clock frequency you can give, or this is with which clock frequency your compiler is going to synthesize your design. Input delay, output delay, you can keep them as such, no need to update them. Here the other two parameters are link library and target library. You will have to provide this compiler a set of standard cells so as it to translate your code into Verilog to a netlist file. So for that it is making use of standard cells, and I have given that location of standard cells over there at both the link and the target library. So that's all. Thereafter you need not to update anything over there. To get out of this script, command is :wq. It will take you out of that. And now the command that you need to run so as to execute that script is dc _shell -t space -f synthesize.tcl. This script will automatically invoke the design vision, will translate your synthesis, will fetch the reports and close. Now it has been completed because my design is not very complicated. It's just a simple mux. If you look into this, you will get to know about the area parameter. Like my area is 464, it's in micrometer scale, and it will generate certain other reports as well to you for your detailed analysis. The one is cell report, which will give you your area being consumed by that design using standard cells. All these reports are with reference to those standard cells only. So it will be picking up the small primitives out of those standard cells available to us, and we'll be generating all those figures based on those standard cells. So we are having cell report with us, power report is there, and timing report. So it will give us a complete analysis of our design. Let's look into each of them one by one. Power report. So my design is having a cell internal power of 74 microwatt, switching power 70 microwatt, total dynamic power is 145 microwatt, and the leakage power is 801 picowatts. So my power report is complete in all aspects. I'll get to know about my leakage power as well as dynamic power. There comes the cell report, which will give me the idea about my area being consumed. So here you can look into, like, because I have shown you my Verilog code as well, in which I haven't defined any gate into it. It's just a very behavioral fashion in which I have coded that multiplexer. But here, if you look, my compiler has simulated that design using inverters and or invert, and in total it has used 17 cells whose area is approximately 464 micrometer square. So you get to know about the area report as well. The other one is timing report. Now if you look at a timing report, since we have given a clock frequency of 100 megahertz, that corresponds to a time pulse of 10 nanoseconds. So my clock having a falling edge of 5 nanoseconds, and at a falling edge it will take 0.31 nanosecond for my input to reach the output. So my delay for this circuit is 0.31 nanoseconds. I'll get to know about my propagation delay, power, area, everything is complete. Now it is also generates few other files for you that you can eventually import into Cadence for the layout generation and extract the spice parameters. Those files are, if you look into this is the netlist file. One netlist file is being generated, that is here it is, mux 2.1.mapped.v. If you look into this file, it will contain a netlist file, like my analysis of that design using primitive gates, which are available in my standard cell library. One file is .sdc. This is that file which I will be importing into my Cadence encounter for the layout generation as well, because encounter Cadence as of now is not available to us. So as of now we have reached till that step only. As Cadence got up and we get to know about the layout generation steps as well, I'll be preparing another video tutorial showing all those things to you. Thank you for watching the video.